the mode of heat that is most suitable in gases is convection. Now, it is not just limited to gases. We also have it in liquid, but we usually consider um, gases when it comes to convection. So number two, the answer is temperature. That's the definition of temperature. Now, land and sea breeze is a real life application of convection, because the definition of convection itself is a process by which heat is transferred through the movement of heated fluid. When we say heated fluid, that's air. Do you understand? So number three answer is convection as well. Now, the only cycle that um converts chemical energy into thermal energy is the Otto cycle. So in most cases, is either it converts from the chemical energy to thermal energy, then finally it moves into the action of motion. So the right option for number four is option the answer is option B, that's Otto cycle. Um, the first law of thermodynamics is related to law of conservation of energy. That is, energy can neither be destroyed nor created. So that's option D. Then number six, a system that exchange neither matter nor heat with the surroundings is that's an isolated system. So it does not give both matter and heat to the surrounding. So that's isolated. Then when a gas is compressed at constant pressure simply means that's an isobaric process, yes. So that's option B. Then the last one, number 8, for an isobaric process, work done is given as P change in V. That's option A. Now, unlike isochloric process, assuming it is an isochloric process, the work done for an isochloric process is equals to 0. So that's just, you should take note of the difference between the processes. To find we have a tin melting at 233 degrees Celsius. So in this question, we have two different scale. We have the Celsius scale and the Fahrenheit scale. And you notice that what we are asked to look for is the value of x, that is the upper point of the Fahrenheit scale. We have, using this table, the right method to do is we subtract the down limit, that is the lower limit, from the highest upper limit, that is the boiling point from the cooling point from the freezing point, that is the cooling point from the boiling point. So we have 232 minus 0. Similarly, we have 100 degrees Celsius minus 0. So we equate it to x minus the the melting point of Fahrenheit. So that's x minus 32 over 212 minus 32. So when you solve for the value of x, we have our value of x to be 449.6 degree Fahrenheit. So that's option C. So we'll move to the next question. Number 11, not number 12. Question 12 asks us to look for question 11 asks us to look for heat capacity, and that's mass times the multiplied with the specific heat capacity. So that's 20 times that. So we have our answer to be 4.7 joules per Kelvin. Similarly, for question 13, that's mass times that. So mass times specific heat capacity. So we have our final answer to be 0.64 times 10 raised to power minus 4 joules per Kelvin. Now, question 12 is a question on linear expansivity. Now we have alpha to be 1.1 times 10 raised to power minus 3. We have a change in length, and they ask us to look for the initial length. Then we have change in temperature. So we use our formula, then we find our L naught. So that's Question 12, that's option C, 45.45 meter. So we have the next question is, what temperature will the Celsius and the Fahrenheit scale record the same reading? So when we use F minus 32 over 9 equals to F over 5. Initially it is meant to be C over 5, but since it is saying the temperature at which the Celsius and the Fahrenheit scale will record the same reading, so we equate the two of them together and we have F to be minus 40 degree. So the right option is option D. Then quickly to question 18, we have an ideal gas occupying a volume of 1 liter at 1 atmosphere 1 atm. So we have our pressure to be 1 atm. Then we have a change in temperature to be negative 50 degrees Celsius. So using P1 over V1, P1 V1 over T1 equals to P2 V2, we apply the necessary parameters and we look for V2 of which they ask us to look for. So our final answer is V equals to 0.45 liter. Then question 15, if you place your hand underneath but not touching a hot kettle of water, the heat felt is mainly from, this is pure radiation, that is the heat is radiating. You understand? So that's option B, radiation. So the second law of thermodynamics is related to entropy. The second law states that the total entropy of a system either increases or remains constant. So that's the second law. So the the variable related is entropy. So question 17, the process at which internal energy increases exactly by the amount of heat on the system, that's the adiabatic process. So we are done with question 14, 15, 16, 17 and 18. So we'll move to the next questions. So moving to the next question, the following shows the work done by a system. Now if the work is done by the system, then it is done on the surrounding or in the surrounding. So that's the A, work done is less than 0. So we have the correct representation of first law of thermodynamics is option B, that's change in U equals to Q minus work done, quantity of heat minus the work done. So converting 60 degrees Celsius to Kelvin, you use C equals to K minus 273. So you add 273 to 60, so you have 333. Then the next one, converting, same process, use the formula F minus 32 over 9. We have our final answer to be 104 degree Fahrenheit. So alternatively, you can also use 1.8 Celsius plus 32, where C is the given value. So once you insert your value, you have 104 as well. Then the three ways to transfer heat, of course, those are conduction, convection, and radiation. That's option A. Then 25, the first law of thermodynamics can be related to, that's option A, that's QH minus QC. So that's question 5. So we'll move to the next questions. So the temperature that's what temperature will the Kelvin scale and the Fahrenheit scale record? When will the temperature of the Kelvin scale and the Fahrenheit scale record the same reading? So this is when we have 373 minus 273 over K minus 273, just like the previous one we did earlier. So at the end of the day, we equate F. Anywhere we see K, we represent it with F. Then we simplify and have our final answer. So we have it to be F equals to 576.6 Fahrenheit. So similarly for question 28, you see that question 28 we are asked to look for the pressure, and from ideal gas law we have P equals to nRT. So making P the subject of the formula, we have our final answer to be 3.74 times 10 raised to power 2 Pascal. So the next, for question 27, the best statement that defines entropy is the measure of disorderliness in a system. So that's option C. Then question 29, what is the amount of heat that must be added to that of steel ball in order to increase its temperature by 30 Kelvin? So using Q equals to MC changing T, we have question 29, we use Q equals to MC changing T, and we have our final answer to be 5388 joules. That's option D. Then for question 30, the question 30 is saying that by how much will the temperature of the ball increases in question 29. Sorry, that should be in question 29. Increases if it were made of gold of specific heat capacity of that. So in this case now, they gave us a different specific heat capacity, so we are asked to look for the change in temperature. So we use the same heat which was gotten from question 29 to look for the change in temperature, and at the end of the day we arrive at 104.4 Kelvin. So that's option A. So that is that. So for question 31, we have a sealed vessel containing a gas at a temperature of 27 degrees Celsius. Now we have to convert the 27 degrees Celsius to Kelvin by adding 273. So that's 300 degrees Celsius, 300 Kelvin. So what is the final temperature of the gas if the pressure is doubled? Now when a pressure of a body is doubled, definitely the temperature is also doubled. So that's 300 times 2, so that's 600 Kelvin. So 31 is option B. Now 32, we use the same formula we've been using, Q equals to MC change in T. Then we look for the value of T, and we have T to be 82 degrees Celsius. Question 33, one of the given option is not a type of thermodynamic cycle. Obviously heat engine is not a type of thermodynamic cycle. Then we have question 35, the expression that best describes thermal equilibrium is that's option D. So I'll leave question 35, you sort out the answer for question 35 yourself. I mean question 34, sort out the answer of question 34 yourself. So question 39 says that the temperature at which the properties of a gas approaches zero is negative 273 degrees Celsius. So question 36, question 37, and question 38 will be as your personal assignment. So sort out the answer of the following. Thank you, and don't forget to subscribe to this channel. Thank you very much.